Okay, good evening. Hopefully you can all hear me. I'm going to say a few words before I start so that you can get used to my bad Australian accent. I am not from Australia. I'm from London. I live in Austin, Texas. I've lived in Austin, Texas now for 7 years. Before that, I lived in New York for 2 years. So I have a very confused English accent now. So I'm going to try to speak fast because I have some important things, some important messages to give you, right? But I'm going to try to speak clearly because I am wasting all of our time if you don't understand what I say, right? So, please ask questions, but we're going to go through this as quickly as we can. Both Geoff and I, at the end, would welcome your questions. All right? I'm going to try and give you some ideas on some of the key things that are going on in the software industry now and in the computer industry. I've worked for, I guess, 12 years in teams that have been globally distributed. 10 years ago, I was at IBM. We were working with a team of software programmers in Beijing, nearly 50 programmers, plus a test team, a quality assurance team. So I'm going to talk about some of the experience I've had then and since then. So we're going to talk about that, the challenges and opportunities of working in a large corporation. Lots of people find working in big companies intimidating. I would tell you the opposite. It's actually a really exciting opportunity. If you get to learn how big companies work, get to learn how to exploit the opportunities they give you, you have many more opportunities with much less risk working at a big company than you do at small companies. When I joined Dell 4 years ago, I had no idea I was going to end up working for a private company, right? And 4 years ago, Dell was a public company. It had stock. Investors invested in the stock, and they had no real concern about the technology. They were just interested in the profit from the company. Michael Dell has completely changed the company in the last year by repurchasing all that stock, and he's now going to drive the company based on the technology that we're working on and the opportunities that we have in front of us rather than the company that we used to be 5 years ago. So it can be really interesting. In my time at IBM and even here at Dell in 4 years, I've essentially had 3 different jobs in 4 years, and they've all been great opportunities, right? To do something new, to do something exciting. And I didn't have to leave. Leaving companies and moving between different organizations, is actually difficult. It slows you down. It gets in your way. And you can make mistakes. So what I'm going to try to do is share with you some thoughts that I have on working in a large company. We're going to talk briefly about what Dell is doing. I'll give you some ideas on what Dell is doing as a company. And then Geoff, who is here regularly in Zhuhai, Geoff will talk to you about some of the things that we do here and some of the local opportunities. So that's my agenda for this evening. In essence, today it's all about speed. It's critical for competitive reasons to stay ahead, right? And that is part of what we're doing now at Dell, is we have to get back ahead of the competition instead of reacting to what's going on in the market and in the industry. It's time for us to get back into leading. There are lots of things that Dell has done and still does that are industry leading. A number of our servers are industry leaders. You would be surprised how many of the big companies that you know from the internet era run exclusively on Dell equipment, on Dell servers. If you go to California and to Nevada, to the desert in Nevada, there are whole blocks of Dell servers running outside. So they run outside of buildings, they sit on the roofs, so they're much more like industrial components than traditional IT data systems. So they run in, we were one of the first companies to make servers that were supported and sold to run in up to 140 degree Fahrenheit temperatures. At one of the universities in Austin, in Texas, at the University of Texas, we're actually now manufacturing and building and doing tests on servers that run in vegetable oil. So the servers themselves are completely submerged inside vegetable oil. It turns out that vegetable oil is a great conductor and coolant. So we're trying to work out on the hardware. But more importantly for Dell now is, what are the future opportunities? So where do we need to be in 5 years as a company? What are the technology opportunities? So those are some of the things that are changing. People's expectations of computer systems now are very different from what they were 5 years ago, 10 years ago. Most of us now wouldn't put up with an email system that wasn't available all of the time. 10 years ago, you sort of had this begrudging acceptance of systems that were down at the weekends because they had to update the software. No one would tolerate that anymore. So people's expectations of what they want from a system are very different, and we have to change the products to meet that. And that requires you thinking about how you design and develop systems. So it's a very different world now in many ways, as well as being much more interconnected than ever before. In my introduction, I did work on the world's first home banking system. When that system was put into production in 1982, which was probably, you know, when your parents, some of your parents may have still been at school, we didn't have modems. There were no modems then for home computers. We used to use the telephones and connect them to acoustic couplers. They made the noise of fax machines. So it's a very different world now, and we need to think about that differently. I have to tell you that one of the most important things that we need from you as a generation of technologists is to treat engineering as the profession that it is. Right? I mean, we still, in the computer industry, to a large degree, don't treat engineering as seriously as we should. Increasingly, the software and systems that you work on are going to find their ways into implementations that are critical to people's lives. You know, 5 years ago, no one would have thought about self-driving cars. Aeroplanes that landed and that could do guidance in the sky were still not well understood. It is the case that in a few years' time, you know, everything that we do, all the critical systems that we're involved in, will be computer controlled. And so that puts a requirement on you to treat engineering seriously and as a professional skill. A lot of people still feel that building computer software is kind of an experimental game. Well, there is an element of experimentation to it, but we need to be much more like construction engineers. No one builds bridges anymore that fail, right? Buildings you know, as we see from the constant stream of disasters around the world, we need to think much more about buildings. And if we're going to put sensors in those buildings and the opportunity to make the buildings smarter, to sense what's going on in the environment around them, we need to treat that much more as a profession than we've previously done. So it needs to be treated much more as a discipline now. So I would encourage you to all think about, you know, that and the requirements, right, in terms of the systems and the infrastructure and the way that you construct programs. So again, I think it's you know, as much as the industry has changed, the requirements have become much more important now to think through how you do that. You know, in the old days, it was all focused on transaction systems and financial systems and maintaining the integrity of those. Now, increasingly, in the modern world, it's much more about the reliability and the availability of those. All right? One of the things that I've learned over the years in managing and working in distributed teams is that culture is critical. And I know from my experience that your culture is very different from ours. But we, as a business, right, you as employees, you as users of the technology that we produce, we need you and us to find a way to bridge those cultures. If you're going to work in an engineering organization or in a global software development organization, you do have to understand some more about culture. One of the big challenges with a globally distributed project is being able to hand off the technology that you work on, being able to communicate with the other teams, whether they're in Asia or in Europe or in the Americas, increasingly, and in South America is a big technology opportunity, in India. So it is a big challenge to understand that, right? And there is a difference between what I think a lot of people think of these days as global technology distribution. You know, it's not often that you get the chance to work in just a group of 2 or 3, right? Versus the long tail effect of working in a team of 100 or 200, right? I mean, if you work in a big team, your communication skills, both written and verbal, and your confidence to communicate in those becomes increasingly important. All right, so I think those are key things, and the way that you approach those has a big bearing on your success, both as a team and as a person, right? Your ability to communicate, your confidence. We see this, and this wasn't a randomly chosen picture to illustrate this point. This was very carefully thought through, right? It's not how you do things. It's not the fact that you just do surgery on someone. It's how you do it. Being able to communicate and record. If you go watch a surgical operation, again, they're much more focused on how they do it rather than what you're doing. Right? All the instruments have to be tracked. They communicate. If you watch a surgical team, a real life one as opposed to one on the movies or on television, if you watch a real life surgical team, it's a really clearly communicated process, right? They're constantly, each person has a role and they're all constantly communicating just the facts that they need to communicate. And that is just as important in software development or in a globally distributed team, right? It's great to always tell someone when you're asked that you're doing well, the project is good, that we're being successful, that we're achieving our objectives. But it's equally as important to communicate when things are going badly, when you're not able to meet the objectives, right? And as you work in a globally distributed team, being open and transparent about that communication is really important, right? Not because you're going to let down people if you tell them that things are going wrong, if they're going badly. What you're going to do is you're going to give the people that are organising the project and managing it the opportunity to recalculate, to replan, to take into consideration what changes they need to make. In my time in New York, working there, you could often, everyone worked in, it was a very old-fashioned building, everyone had closed-door offices. And just like this in the evening, it would be dark, there was no light outside, there were low lights in the corridors, and you could tell people that were still working late in their rooms because you could walk past and see the light under the door. And we would walk round in the evenings and go and ask the programmers how they were doing, what problems they were working on. And often, you know, in the old days, we used to work on waterfall programming, which would be, you know, you start and 2 years later, the product is ready. And if you have months of delay, you could hide it then. You could hide your problems. And so you wouldn't find out until right at the end that something wasn't working. That's not the industry we're working in now. We're working on monthly code releases. Some projects release code every 2 weeks, every 6 weeks. So your ability to actually ask questions, to make sure you understand what you're being asked to do, to make sure that you understand the interfaces, the design specifications, that is almost as important as being able to write the code, right? Being able to understand and communicate, and then, you know, be honest and transparent when things aren't going well. You know, nobody hates you because you can't do the job, right? People hate you when you pretend you can and don't do it, right? Everyone wants to be successful, right? Your success is our success, right? So, you know, if you tell people and communicate that you don't understand, that you need help, right? Early on, there's plenty of opportunity to help you, to make sure you understand. So doing those, especially when it's globally distributed, when maybe there's 2 or 3 of you working on one project in Zhuhai, or in Beijing, or in Bangalore, or in Mumbai, or in Delhi, or in Argentina, Brazil, being able to communicate over the telephone or in email clearly that you need help, or that you're, you know, or that you think one of your colleagues needs help, is just as important as being a successful superstar programmer, right? So communication, right? It's almost better to over-communicate than not communicate at all. And, you know, incremental works. You know, we've seen and we see now increasingly the ability to actually do small steps, increment on it, get feedback, change, feedback, change, talk to the customers, understand what they want, plan what you're going to do, and so on. So those are all key attributes of working in a globally distributed team, as well as they are in small teams. One of the big challenges that we've had in the past is that I think a lot of people look at architecture, especially for software, as something big, right? Architecture is big, it's thought through, it's heavyweight, It's not true. That isn't the way that architecture should be. Architecture should enable everyone to work in a common way across the projects and the products that they're working on. It shouldn't be a roadblock, right? So if you get to work on architecture, whether you're the consumer of software architecture or whether you're a producer of software architecture, you really have to think about it as an enabling technology. It's there to help you, right? If you work on projects where you think the architecture is getting in the way, then that's a good time to communicate. But what you must remember is that the architecture has to be fit for the purpose that it's being used for. So the same as we talked about earlier as engineering being a profession, right? You've got to have a suitable architecture. The engineers must produce a suitable architecture for use in the environment that that it's being used in. So at Dell now, we're traditional. You know us for producing hardware. I think a lot of people would be surprised, as I was when I joined Dell, at just how much design and engineering we did. I mean, there are some really unique hardware designers at Dell that have done a fantastic job over the years. Most people assume that we just assemble, we buy ready-made components and assemble them into PCs and servers. That is not the case. But in terms of opportunities now, it's not just to do this very nice hardware, it's to actually take a holistic view of the complete system and both the software that runs on it, the networks that connect it, the storage that runs in it, and try to produce a more complete solution for customers. So that's really where we are at the moment, is working on this horizontal integration from the network down through the servers into the storage, the way that memory is used and so on. So that's one of our current areas. What we're doing now, though, is moving away from that by trying to produce architectures that let us incorporate many of the new technologies and broaden out the solutions that we're building for customers in a much more holistic way. In terms of the Dell software business itself, the real focus for us in the software team now is to take that much broader business opportunity and look at software there where we can help customers transform, connect, inform, and protect their environments. So, those map into both hardware and into a broad software set of solutions. Right? What you'll have seen, or you may have noticed, is we've spent the last 3 years acquiring software companies, both very focused small software companies, the most recent of which was Stratius, which is a multi-cloud manager that allows you to manage and deploy onto different cloud environments, right through to traditional management vendors that do desktop and device management, right, like Case, SonicWall, which is a traditional software company in security that has a number of security devices. So those are some of the ones that we've worked on. Our biggest acquisition, though, has been Quest Software, which, as Geoff is going to talk about briefly for us in a minute. So across all those areas, we're now looking to extend those solutions and those products. In terms of the solution areas, they really map into what's going on in the industry and where we think that's going to go, right? Around data center and cloud management, increasingly information management, right? you know, I'm always amazed at whenever I use either my Yahoo Mail or my Gmail account, how incredibly hopeless, useless their advertising is. You know, they put targeted advertisements up which make no sense to me. You know, so there's obviously a huge way to go in terms of analysing the data, to managing the data, and being able to turn all that data into useful information. So I think, you know, this big data analytics is, you know, is a huge opportunity. Mobile workforce management, again, you know, is there anyone in the room here that doesn't have a mobile phone? Right? You know, soon you're all going to be at work, right? No one wants to use a separate phone. I still see my peers come into meetings, they're carrying 2 or even 3 phones. I just won't do that. If I can't manage with the phone I've got and do my business and my private life on it, I'm not interested in carrying chargers. And so we've got to get a lot better and a lot smarter, and that is one of the areas in terms of workforce management, and that whole area now is one of the growth opportunities. And then, you know, underpinning all that is privacy, security, being able to manage the data. So those are all big areas for Dell in software. Some numbers for you, just to give you some idea in terms of where we are in software. We have already over 6,000 employees, right? There are over 6,000 Dell software employees, everything from sales to back office to programming, architecture, and engineering, all right? We already have 2 million community members using our different software and the community social media parts of that. We've won a number of awards already. We have over 1 million customers. So those of you that only know Dell as a hardware company through the PCs that you've bought, it's actually a very different company already, and is going to change even more so over the next 3 to 5 years. Especially now as a private company, our investment versus our profit is really what's going to drive the change in the company. Whereas before it was all about profit, which in a declining market for PCs, which have a very low profit, there's very little profit in PCs these days, right, is what was driving the company for the last 3 to 5 years. Now we're a private company. It's much more about investment. It's much more about future opportunities. So I'd like to introduce Geoff now. Geoff is going to talk to us about the investment that we're making here in Zhuhai and give you an idea of how we're doing that, because we think that is different from typical offshoring activities. So, Geoff?
Thank you. I'm not from London like Mark is. I have a regular English accent. I'm from Canada, where English was invented. Okay, so I'm going to talk about our Zhuhai lab, and in order to do that, well, I want to accomplish 2 things. I want to talk about applications and application monitoring, and the reason I want to do that is that's going to tell you what we're doing here. And I want you to really understand it, because I think it's something that's very different for students in a university. And here's why. If we have a look at a typical, I call this the typical software developer's perspective. You write code, you write programs, it's fun. I used to do it too. I miss it. And when you do that, you write it and you put it on a computer and it runs. And that's your perfect world, right? That's what happens. You take your code, you run it on a computer, it does something, everybody's happy. Is this reality? This is not reality. This is not the way the world works, especially now. It may have been the reality maybe 20 years ago when you could write a standalone program and it would execute in a very constrained environment. Today, things look an awful lot more like this. You might take your code, and it doesn't run on just one machine. It runs on 3 machines. You don't even get to control how many of those there are. And it runs as part of an application architecture that includes other machines. Maybe you wrote the web server code, and it talks to an application server, which talks to a database, which talks to another application server that you don't even have in the same company. This is what applications look like today. This is what Facebook looks like. This is what Twitter looks like. This is what every application looks like. So the application code, the code you write, is really only a tiny but important part of the whole picture. And that's where we come in, okay? Because what we do is handle everything that happens after you write software. So if your software does something that someone actually cares about, in other words, it's a worthy program, you need to think about how to keep your software running. So you need to make sure it's running, and if it's not running, someone needs to know, and you need to get it going again. You need to know if it's performing well. Someone will take a phone call about complaints. You'll need to fix that software. You'll need to upgrade it. You don't get to write it just once and then start a new program. You have to keep fixing that program, maybe for years. You may have to have a staging environment in order to test new versions, because you can't just take your latest bug fix and throw it out in front of customers. It might not work. You need to keep the hardware running. So if the hardware fails, you need to maybe get some new hardware. You need to know if a CPU is running too hot. Most software developers don't think about this world at all. It's a very important part of the world. Successful software requires attention. We need to make sure that it keeps running, and that's where we come in Zhuhai. So really quick definition. An application is really a collection of software and hardware that provides some kind of a service. And most applications today are on the internet. So they are web-facing or internet-facing. Applications can be internal or external. I'm just going to move along a little quicker because Mark talked for so long. Just kidding. So this is what an application looks like, or this might be a structure for an application. So you're going to have the web browsers here. You might have some kind of network infrastructure. You'll have maybe web servers and app servers like Java or .NET and databases at the back end. That's a pretty straightforward contained application. Very few applications look like this anymore. Most look a little bit more like this, where you're going to have web services and information buses and communication between applications. These days, applications don't stand alone. They have incredible dependencies. They may depend on services that you have no control over. You may call a web service to get weather information over the internet and use that in your application. So very complex, lots of tiers, different tiers in the application itself. I don't mean crying. Although there are lots of tiers in application development. So what we do in Dell software, or what I really care about, and what Yinghua works on, is application performance management. So this is a discipline that makes sure that an application is available and is performing properly. So there are really 3 important parts of this. The availability, is it running? Performance, is it running fast enough? Or is the response time 1 second or 20 seconds? And then the business value, is it actually delivering the service that it needs? So it doesn't matter if it's fast and up. If it's so confusing that people don't even bother to buy anything, that's also something we need to track as part of application performance management. So these are some of the things that we can measure along those 3 important areas. You can measure the uptime of a server. You can ensure that a URL responds. You can look at the workload in terms of performance. You can look at the workload, so resource utilization, how much CPU am I using? Am I waiting around for CPU in a virtual environment? How many transactions am I running? How many method calls are being made? Lots of different metrics. And then, of course, business value can be very dependent on the application itself. It could be the number of completed transactions. It could be the number of dollars that you've made today. It could be the number of dollars per transaction. We'll skip that slide. So here are some of the different application platforms that exist. And these are all things that we try to manage at Dell Software. So we might try to look at the infrastructure itself, so the different operating systems, Windows and Linux and Solaris and AIX and HPUX, and also different clouds. So we are able to monitor Amazon, or we're able to monitor Azure. There's also virtual infrastructure to consider. So maybe somebody isn't running just physical servers anymore. Most likely that's true. So we are able to monitor VMware and Hyper-V and LPARs and zones and all kinds of different virtualization technologies. Today we were looking at Power VM as an example. Web servers, IIS, Apache, Tomcat, all the major databases we do as well. Custom applications written on Java and .NET, and we're getting into Ruby, PHP, and Python, and Node.js. Packaged applications is another thing that we monitor. And of course the cloud platforms for applications like Azure. These are all things that we are concerned about as part of the application performance management discipline. So what Dell does is we have this product called Foglight. And Foglight is a monitoring platform, and it monitors all those things we saw on the previous slide. So we do infrastructure monitoring storage, web servers, databases, everything. We'll tell you if it's up and running, we'll tell you how it's performing, and we'll tell you about its business value. And this has been sold to literally thousands of customers all over the world, including some very big installs. We're talking about customers who have hundreds of thousands of virtual machines. So this is a very large piece of enterprise scale software. And it looks really pretty too. This is a screen snapshot from the upcoming product. It's going to end almost exactly on time. And we do an awful lot of the development here in Zhuhai. Okay? So we have 200 people, over 200 people in our Zhuhai lab. 120 of them work indirectly for me in performance monitoring. So that's led by Yinghua and her colleague Flora Li. We have QA and development and escalations. And the Zhuhai lab is our largest Foglight lab in the world. So we have labs in Toronto, where I'm from, and Tel Aviv, and San Diego, and Boulder, and a few other places I can't remember. But the biggest one is the one that is here. And we've had a lot of success here, and I believe we've had success because we followed a different model. So the traditional model is to take some of the code that you're running that you don't care about anymore and then send it over here to be maintained. That's not what we started out to do, and that's not what we do at all. What we do here is new development, and we've done a lot of new development. Our next generation APM platform development is being done on Yinghua's team. Okay, there's a lot of involvement with the folks in Toronto, so there's a design interchange and interchange of ideas. But this is a partnership, so we don't dump old code in China. That's not what we do. We develop new code in China because there are a lot of smart young developers here. And it's also not very cost effective to take code and transfer that knowledge to someone else. It actually costs time and money, and it's very hard to do effectively. So we don't do that very often. So like I said, our next generation APM product is being developed here. We do escalations and field support for local customers. So we're really big on selling APM in China, and we have a connection between our QA team and our development team and customers here, banks and insurance companies. So the bottom line is that the lab here is absolutely critical to the success of our performance monitoring business. And that's why I'm here every 2 to 3 months to make sure everything's going okay. We have huge numbers of interactions, and I've been here more than Yinghua lately. But that's the quick overview of what we do and background on Dell. And I guess at this point we'll take questions, because I'm done and Mark's done. I hope there are questions.
So any questions? Anything you'd like to know about working in the software business, software industry, anything in general?
Nobody can leave until there's at least one question. It's going to be a long night.
Can you describe Foglight again?
Can I describe Foglight again? Yeah. Sure. So it is and maybe more slowly this time, it is an enterprise monitoring platform that we've built. It's able to monitor anything from any domain. And the way that we do that is by taking the data that we gather and transforming it into object-oriented models and then storing it. And we have built monitoring for Java and .NET, all the things that are on that list. In fact, we've been able to change our collectors, change the domains, and in a number of cases keep the models the same. So we've got an advantage just based on the platform that we use. So it's a large platform as well as a whole bunch of plugins and add-ons that create products on the platform. You can think of it as an application server for monitoring.
Okay, so what kind of enterprises are you servicing now?
What kind of enterprises are we
Servicing.
I'll probably give some examples. I'm not supposed to by accident, but pretty much every large bank in North America is a customer or has been a customer. So Bank of America would be an example. Merrill Lynch, JPMC, large insurance companies use our product, but also small startups that are doing monitoring, so travel websites, job websites, they use our product as well. The Apple Store uses our product to monitor some of their infrastructure, as an example, which is a cool example.
Most like all the big corporations. Is there any small ones?
There are lots of small ones. So when I said thousands of customers, the bulk of those thousands of customers are small customers who've downloaded our product and installed it themselves. So I don't know them by name because they aren't large installs. But there are thousands of these customers, and they are smaller companies.
All right.
Okay.